Hello everyone. In this video we are going to discuss metals and non-metals. Okay, so let's start the concepts. First, introduction. When we talk about metals, okay, so metals are generally elements which are electropositive in nature. Okay, electropositive in the sense means they have generally tendency to lose electrons like sodium, aluminum, magnesium, whereas non-metals are electronegative elements which have tendency to gain electrons like chlorine, oxygen, sulfur. Okay, we will discuss this okay, in the later part of the chapter. Now first see what is given here. Metals is a mineral. Okay, it may be element, compound or alloy that is typically hard, opaque, okay na, shiny and has good electrical and thermal conductivity. Okay, so when we talk about metals, what comes in your mind? Iron, yes or no, is a metal. Copper, silver, gold, all these are what? All these elements are metals, yes or no? Even when we talk about alloy, okay, like brass, bronze, which is a mixture of two or more metals, okay, yes or no? So metals are present in the alloys also, yes or no? Next, copper was the first metal to be used for making utensils and weapons. Metals are generally good conductor of electricity and heat. For example, sodium, potassium, lithium, iron, gold. So most of the metals are generally hard, okay, but there are some metals which are soft and can be cut with a knife, okay, like cesium, okay, lithium, sodium, we can cut with a knife. Okay, most of the metals are strong and have high tensile strength. Metals are generally solid at a room temperature except mercury. Okay, next. When we talk about non-metals, so non-metal is a chemical element, okay, that does not have the properties of a metal. So they can either be gases or elements that do not look like metals. For example, carbon, sulfur, iodine, okay, oxygen, hydrogen. Okay, non-metals exist in all the three steps. Okay, solid, as a solid, what are the examples of a solid? Like carbon is a non-metal, yes or no? Liquid, okay, bromine, iodine, okay na? And gases, most of the non-metals are gases like oxygen, chlorine, fluorine, okay, nitrogen. So non-metals are not able to conduct electricity or heat as well. So non-metals are generally poor conductor of heat and electricity. Non-metals are tend to be highly volatile. Properties, when you talk about properties, non-metals are not hard, okay, they are generally soft, okay, rather than they are generally soft. Non-metals may be solid, liquid or gas. Non-metals have dull appearance. Exceptions, diamond and iodine are the exceptions, yes or no? Now let's discuss some physical properties, okay, of metals or non-metals. When we talk about the physical properties, okay, so malleability, ductility and conduction of heat is most important. When we talk about malleability, malleability is nothing but the ability of a substance to be beaten into thin sheets. So metals are generally malleable, non-metals are non-malleable. So you have seen the sheets of aluminum, iron, copper, yes or no? So you can see here malleability can be beaten into thin sheets. So metals are malleable while non-metals are not malleable, okay. Ductility, ductility is nothing but it is the ability of the substance to be drawn into thin wires. So non-metals are generally non-ductile whereas metals are generally ductiles. You can see here, can be drawn into thin wires. Metals are ductile whereas non-metals are not ductile. Conduction of heat, metals are the good conductor of heat, non-metals are generally bad conductor of heat, but some exception is there. Here exception you can write graphite. Graphite is a non-metal which is a good conductor of heat, okay, and electricity. Okay, good conductor, silver and gold and copper, they are very good conductors. Bad conductors like mercury is a mercury is a metal which is generally poor conductor of heat. Okay, yes or no? So these are the some properties. Now conduction of electricity, metals are good conductor of electricity, yes or no? So we have seen the wires of iron, copper, silver, yes or no? Non-metals are generally bad conductor of electricity. Appearance of surface, metals generally in the pure state they have shiny surface, okay, metallic luster is there, yes or no, whereas non-metals are generally non-lustrous, means they do not have a shiny surface. Non-metals do not have a shiny surface, exception iodine is there, okay. Diamond also you can see diamond is lustrous. Metals are reacting with gases in atmosphere and lose its shiny appearance when it kept in air. So metals undergo generally corrosion. Okay, iron, silver, gold no, iron, copper, aluminum. Okay, so they get corroded in the presence of atmosphere. Okay, next, physical appearance of metals or nonmetals. Hardness. When we talk about the hardness, okay, metals are generally hard. Okay, exception sodium and potassium. Density, metals have high density except sodium and potassium. Melting and boiling point, metals have high melting and boiling points except sodium, potassium, mercury, cesium and gallium. Cesium, if you keep on the palm, okay, what will happen? It will melt. So it has very low melting point, same as mercury you can see. State at room temperature. Metals are solid at room temperature exception mercury. Non-metals present in all the three states, solid, liquid and gases at room temperature. Okay, sonority is nothing but the property of producing sound on a striking a hard surface is called as sonority. So metals are generally sonorous, non-metals are non-sonorous. So exceptions of physical property you can remember. Graphite is a non-metal but it is a good conductor of electricity. Diamond is a non-metal but with a high melting and boiling points. Diamond, an allotrope of carbon which is a non-metal, is the hardest substance, and iodine is the lustrous non-metal. Yes or no? So reactivity of metals with a metal salt actually. Okay, so reactive metals can displace less reactive, more reactive metals can displace less reactive metal from its salt solution. Okay, for example, okay, iron react with copper sulfate, it gives you what? Iron sulfate plus copper. So we have a reactivity series in which elements are arranged in the decreasing order of reactivity. Like potassium is most reactive, potassium, then sodium, calcium, magnesium, aluminium, zinc, iron, hydrogen, yes or no, copper, then silver, then gold. Okay, so here those elements which are more reactive can displace the element which are less reactive. So you can see here iron which is more reactive. What will happen when you move from top to bottom in the reactivity series? The reactivity decreases. Okay, so here top to bottom reactivity decreases. Okay, here silver is what? Least reactive, whereas potassium is most reactive. Yes or no? Here aluminum plus copper sulfate. Yes, aluminum sulfate plus copper. Zinc plus copper sulfate. You can see zinc. Where is zinc? Here up, which is more reactive than copper. So it form zinc sulfate plus copper. Yes or no? So here you can see potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, copper. This is the reactivity series. Yes or no? Now we'll see the chemical properties of metals. So generally what will happen? Metals react with oxygen, give you what? Metal oxide. For example, potassium plus oxygen, potassium oxide. Sodium plus oxygen, sodium oxide. Magnesium plus oxygen, magnesium oxide. Yes or no? So copper plus oxygen, copper oxide. Aluminum. Okay, one more thing you should remember, what is the nature of these metallic oxides? Metallic oxides are generally basic in nature. Why? Because what will happen? Suppose sodium react with oxygen, gives you what? Sodium oxide, Na2O. Okay na? So because why sodium oxide is Na2O? Because sodium valency is 1, oxygen valency is 2. So crisscross method. So Na2O, sodium oxide. Yes or no? Sodium oxide. Is it balanced? No, not balanced. Here oxygen is 2, this side is 1. So multiply by 2. Now sodium become what? 2 2 4. So here also you should multiply by 4. Yes or no? Now what will happen? Sodium oxide, when it react with water, H2O, it gives you twice of NaOH. Okay, sodium hydroxide. So that's why metallic oxides are generally basic in nature. They are generally basic in nature. Okay, aluminum oxide, okay, which is basic in nature, it will react with acid. It will give you water, salt plus water. Okay, we have learned in the which chapter? In the acid, base and salt, that generally whenever an acid react with a base, it gives you salt plus water. The reaction is called as what? A neutralization reaction. So generally metallic oxides are basic in nature, but there are some metallic oxides which are amphoteric in nature. Amphoteric means they will behave as both acid as well as base. They behave as base as well as acid. So there are few examples like aluminum oxide is there, zinc oxide is there, tin oxide is there. They are generally basic in nature, sorry, amphoteric in nature, means they behave as base as well as acid. You can see here aluminum oxide is reacting with acid, it gives you salt plus water, yes or no? So here it is acid, so aluminum oxide is acting as a base. In this equation aluminum oxide react with a base, it gives you water, salt plus water. Okay, what is the salt? NaAlO2, sodium aluminate. So here as it is a base, so aluminum oxide is acting as a acid. So same substance is acting as a acid as well as base, that's why it is what? Amphoteric in nature. So most metallic oxides are insoluble in water. Some dissolve to form alkalis like sodium and potassium. Okay, so hydroxide which are soluble in water, they are called as alkalis. Okay, now next we talk about a reaction of metal with water. Okay, when we talk about generally all metals do not react with water. Okay, again it depends upon the reactivity series. Some react with cold water, some react with hot water, and few elements will not react with hot water as well as cold water. They will react with steam. So here I am just writing again the reactivity series: potassium, sodium, calcium, magnesium, aluminium, zinc, iron, okay, lead, tin, hydrogen, copper, silver, gold. So what will happen? These first three metals, they will react with cold water. Magnesium react with hot water generally. Aluminium, zinc, iron, they react with steam. Okay, you have to remember this concept is very very important. Some metals react with water to form metal oxide. Okay, and hydrogen gas. Generally what will happen? Metal plus water give you metal oxide plus hydrogen, but some metal oxides are soluble in water, it will give you metal hydroxide. Okay, for example potassium plus water, directly we can write potassium hydroxide plus hydrogen. So you can remember this concepts best. Generally metal react with water, it gives you metal hydroxide. What will give you? Metal hydroxide plus hydrogen. Is it clear? So calcium plus water, calcium hydroxide plus hydrogen, so they will react with cold water. Metals like potassium, sodium react with cold water. Metals like magnesium react with hot water. Okay, they may ask you what will happen when magnesium react with steam. So generally what will happen? Magnesium react with steam, H2O. Okay, in the gaseous form you have to write a steam. So it give you metal oxide, MgO, it will give you MgO plus H2. Okay, magnesium oxide plus hydrogen. Okay, please make a note of this. Okay, generally next what will happen when metal react with a dilute acid? So generally metal react with dilute acid, give you salt plus hydrogen. For example zinc plus sulfuric acid, give you what? Zinc sulfate plus hydrogen. Again those metals which are above the hydrogen in the reactivity series can displace hydrogen from the acid, yes or no? So here hydrogen gas is not evolved when the metal react with a nitric acid. Why? Because nitric acid is a very strong oxidizing agent, so it will convert hydrogen into water. Okay, so nitric acid, a strong oxidizing agent, oxidizes hydrogen produced to form water and itself gets reduced to any one of its nitrogen oxide like N2O, NO2. But magnesium, Mg and manganese react with a very dilute nitric acid to evolve H2. So this is the exception you have to remember. Exception. Okay, next. Metal oxide reaction with water. As I told you, metal oxide react with water, give you water, metal hydroxide. So most of the metal oxides are insoluble in water. Okay, so alkali metal oxides are insoluble in water, but alkali metal oxides gives a strong base when dissolved in water. For example Na2O and MgO. So sodium oxide react with water, give you water twice of NaOH. MgO react with water, give you water MgOH twice. So it's a base of metal. Aluminum oxide and zinc oxides are insoluble in water. Okay, they are amphoteric in nature as we discussed. Zinc oxide can react with a base as well as acid. So they will give you water, salt and water. Okay, so they are what amphoteric in nature. Next, chemical properties of non-metals. Yes, when we talk about chemical properties, reaction of non-metal with oxygen, they will give you what? Non-metallic oxide, metal, non-metal plus oxygen, non-metal oxide, C plus O2, CO2, H2 plus O2, H2O, S plus O2, SO2. Yes or no? Reaction of non-metal oxides with water. Yes, CO2 react with water, give you water, carbonic acid. SO2 react with water, give you what? Sulfurous acid. SO3 react with water, give you water, sulfuric acid. So non-metals react, non-metal oxide react with water, it give you water, acid. Yes or no? Reaction of non-metal with chlorine. Yes, some non-metals react with chlorine, give you water, non-metal chloride. For example, hydrogen plus chlorine, hydrogen chloride, phosphorus plus chlorine, phosphorus chloride. Yes or no? Next, how metals react with non-metals. This is very, very important. Generally, metals react with non-metal by ionic bond. Ionic bond means by transfer of electrons. Okay, so we can see here sodium and chlorine reaction. Sodium atomic number is 11, electronic configuration 2, 8, 1. Chlorine atomic number is 17, electronic configuration 2, 8, 7. So to become stable, okay, as it has 1 electron in the valence shell, so it will lose 1 electron. Yes or no? Sodium loses 1 electron, become what? Na plus. Whereas here chlorine is having 7 valence electron, so chlorine to become stable, it needs to gain 1 electron, so it become Cl minus. Yes or no? Cl minus. So you can this in this way, sodium, okay, which is having 1 extra electron, is donating its electron to the chlorine atom, and Na becomes Na plus, and chlorine become Cl minus ion, and finally they will form NaCl. Yes or no? So the 1 electron is transformed from metal to a non-metal. Okay, similarly magnesium chloride formation, you can see magnesium is atomic number is 12, 2, 8, 2. So it has 2 valence electron. Yes or no? Okay, so 2 valence electron is there. Chlorine 2, 8, 7. It has 7 valence electron. So 2 chlorine atoms are there. So each chlorine atom needs a 1 electron. Yes or no? So Mg will lose 2 electron, become Mg2 plus. Okay, and chlorine, each chlorine atom will gain 1 electron, become Cl minus. Okay, so MgCl2, in this way it is formed. Yes or no? Non-metals. Okay, so you can see here formation of calcium chloride also. Okay, calcium having 2 valence electron, it will give 1 electron to the each chlorine atom, forms calcium chloride CaCl2. Formation of calcium oxide also, you can see calcium atomic number is 20, so 2, 8, 2. So 2 valence electron, oxygen 2, 6, as atomic number is 8. So oxygen needs 2 electrons, calcium need to give 2 electrons, so it will give the 2 electrons to the oxygen atom. So calcium 2 plus is formed and oxygen 2 minus is formed. In this way calcium oxide is formed. Okay na? Here ionic compounds. Okay, properties we should remember. Ionic compounds, a compound formed by the transfer of electrons from a metal to a non-metals. Ionic compounds, metals form ionic bonds when they react with the non-metals. Ions, there are 2 types of ions, cations and anions. Positively charged ions are what? Cations. Negatively charged ions are called as anions. Yes or no? So ionic bonds are formed because of the transfer of electrons. Metals get positive charge because of the transfer of electrons or loss of electron. Non-metals gets negative charge because of the acceptance of electrons. Yes or no? So here the physical properties of metal ionic compounds are there, which is very, very important. Questions are asked generally from this topic. Physical nature, they are solid and hard. Strong inter-ionic force of attraction is there. Ionic compounds are generally brittle. Melting and boiling point, second property, they have high melting and boiling point. A considerable force is required to break the strong inter-ionic attraction. If they ask you why they are having a high melting and boiling point, because of the strong ionic bond we can mention. Solubility, generally they are soluble in water but insoluble in organic solvent like kerosene, petrol. Conduction of electricity, yes, conduct electricity through a solution due to the involvement of charged particles. As the movement of ions is not possible in solid state, do not conduct electricity in the solid state, but in the molten state this movement is overcome due to the heat and conduct electricity. So we can remember that ionic compounds are soluble in water, they conduct electricity in molten state or aqueous state. Okay. Okay, some miscellaneous concepts are there. Okay, the activity series just we discussed. Properties, base metals, properties, reactivity, metallurgy, we'll just discuss in the next videos. I hope you understood these concepts. If you have understood, please share with your friends and subscribe the channel. Thank you.